Today I want to teach you about physics. Well, just the kind of physics you'd use in a simple game. In science class, you learned that the physics of objects that move, we talk about their displacement, their velocity, and their acceleration. Displacement, that's simply distance in a direction. For example, 100 kilometers, well, that's a distance. 100 kilometers east, well, that's a displacement. On a computer screen, if I have an object and I want to talk about its displacement, well, I could talk about it being, 120 pixels, 30 degrees south of east. I could do that. It's weird though. Instead, I'm just going to talk about its x, y location. That uniquely identifies it. Now, in physics class, this is called breaking the vector into its horizontal and vertical components. It's a very common thing to do. The term vector simply means a magnitude in a direction. Let's see how this works in code. So I've uploaded an example called physics1. It's very simple. When you run it, all you get is a red dot on the screen. And all I'm doing to remember where it's at is, hey, box x, box y equals this location. That already is displacement. So it's simple as that. Velocity. You can talk about velocity as being a speed in a direction. Again, I can talk about speed is 100 kilometers an hour, whereas 100 kilometers per hour east is a velocity. For programming, it's easier to talk about it as a change in displacement over time. So again, this guy is moving. I can talk about it as it's moving in this direction. I can break it down into its x and y components of that motion. And all I'm going to do is each time around my main game loop, well, I'm going to add that on. Add that on, and then it's going to move. So take your physics1, save it as physics1. I guess you don't have to if you don't want to. And all we're going to do is move our box x, box y. So box x plus equals 2, box y minus equals 3. Run that, and you see nice movement. It might not be smooth on yours because of the recording. I'll tone that down, and we'll look at it, and there we go. That is velocity. It's moving at a rate of 2 in the x minus 3 in the y. Now, I talk about velocity being a change in displacement over time, but where's the over time? Well, that's the loop. I add this on 20 times per second. That is my velocity. Because it's in a loop, that is the over time. Okay. Real objects in the real world never obtain instantaneous velocity. If you're in a car, you're at a stop sign, you don't instantly start moving at 40 kilometers per hour. Instead, you have to accelerate. You have to build up speed. Now, in physics class, acceleration is caused by an unbalancing force. We don't care too much about that. What we do care about is, well, how do real things travel in the real world? Well, for example, take a ball. If you throw a ball, as soon as it leaves your hand, there's only one force acting on it, and that's the force of gravity, ignoring the minor effects of air friction. So if you take a ball and you throw it with this starting velocity, it's not going to go off forever into space. Instead, it's going to follow this parabolic arc. Well, if you look at this starting velocity here if I break it down as x and y, the x continues on at the same rate. Now you see y keeps getting shorter. That's because there's a force acting on the y. So the y keeps reducing until it becomes negative. And ignoring how trashy my picture is there, that's the basic idea. How does that work in code? Well, I need this 2 and this 3 to change over time. So rather than just adding 2 and 3, I'm just going to name them velocity x, velocity y equals, okay, we'll give the x like 10 and the velocity y like negative 15. And let's start the ball on the left-hand side of the screen, so at 0 and near the bottom, 700. So I'm adding the velocity. Now if I try it now, it's just going to launch off into space. No acceleration anywhere, straight velocity. All I do to get my acceleration due to gravity is I change my Vy in the loop. Changing the Vy in the loop is changing it over time. So Vy plus equals, now in physics class, you'd always subtract from your velocity for gravity. Because our 0 is at the top of the screen, we want to add, I'm going to add 0.25. Now you've been in physics class, you know that real gravity is 9.8 meters per second. Well, the thing is, on a computer screen, I'm not dealing with meters and I'm not dealing with seconds. I'm dealing with pixels per update. So it doesn't matter what number I use. As long as it feels good in my game, that's good enough. And there we go, give that a run. And that's a pretty good arc. If I want the gravity to be heavier, just increase this. And of course, decrease if it's lighter. You might find if you want it to be snappier, not lofting like it's in space, what you do is you make this higher, but you don't want it to be too short. What you do is you also make this higher. So by adjusting these two, you're going to get the physics you want in your game. So maybe you don't have a ball going in your game. Okay, well, speaking about a real game, here's a real game. Okay, it's not a game. I lied. It's a simple example where I have a guy who moves back and forth on the screen, and he can jump. Now you'll notice a couple things. First, the guy's not actually moving left and right. The background is moving. But that's okay, it creates the illusion. But you'll also notice when he goes left and right, it doesn't accelerate. Even though I told you, in the real world, nothing obtains instantaneous velocity, that's okay. It's a game. It's as long as it acts the way I want my game to act, it's okay. But I wanted the jumping up and down to feel more realistic. So I thought it was better if I used gravity there. I've seen games that have them float up and then float back down. If that's the way you want your game to be, that's fine. But I think the jumping up and down looks better if you use a little bit of acceleration. And as you can see from the code, it's not hard. Let's take a real quick examination of this code. So my guy, cleverly called guy, is a list. He has an X, a Y, in velocity y. I don't have to keep track of the velocity x because I'm simply adding on that amount here. So 10 is my velocity x when I'm going left or going right. Well, you could say it's negative 10 when it's left, but whatever. And here, when I hit the space bar, I apply an instantaneous velocity of 10. So it launches him. In the real world, you'd have to bend your legs, you'd have to accelerate. Don't care. As far as we're concerned, instantaneous velocity to start is fine. Every time we're on the loop, I add on the velocity of y to the guy's y position. And then if he goes below my ground line of 0, I set him back to 0, and I set the velocity back to 0. And then I add my gravity here. Now, you may be wondering, why the heck is this negative? A minute ago, I said it had to be positive. Well, sometimes I like things to feel more like real gravity. And so what I did here is I inverted the y-axis. And you do that here by simply saying, rather than drawing the guy where he's at, I'm going to draw it inverted. And for the sake of this example, I'm also drawing the background at a negative position, and that's how I'm achieving that scrolling left, scrolling right. So in a game like this, again, it's not like much of a game, I think of it in two terms. I think of there's world coordinates and the screen coordinates. So my guy, I think of him as advancing in the world. So when he starts the game, he's at spot 0 in the world. This is I call spot 0. I could have called this spot 0. I chose to call this 0. As he moves in the world. But as you can see, he doesn't move on the screen. Whereas the Y, in this case, I only have, well, screen and world coordinates are both the same. Okay, so there's your basic physics, enough to add to your games. I hope you enjoyed the video, and I hope you guys are staying safe. Have a great day.